Let's talk about the unit circle approach for trigonometry. So to start with, let's write the equation of the unit circle. So the unit circle is really going to be just x squared plus y squared is equal to 1. So when you see this word unit, the word unit just means like unit of measure, like that's where the 1 part comes in. So a unit circle is basically a circle of radius 1. So I can label this x value as 1, this y value as 1, this x value as -1, and this y value as -1. Okay. Now, the first thing we want to do is we want to label what each of these angles are going to be. And all of the angles are going to be measured relative to this positive x-axis. So I'm going to highlight that in red. Everything is measured from there. Okay. So that red angle pointing to the right, that's going to correspond to 0 radians. And half a circle is equal to pi radians. All right. What that means is that the positive y-axis is going to be pi over 2 radians, and the negative y-axis is actually going to be 3 pi over 2 radians. And then when you come all the way back to 0, you're going to get 2 pi again. Okay, so a full circle is 2 pi radians. Next, if the angle from 0 to the positive y-axis is pi over 2, then if I cut that in half, I'm going to have a pi over 4 for this angle. That's exactly halfway in between 0 and pi over 2. Similarly, I could fill out the point in between pi over 2 and pi. That's going to be 3 pi over 4. And I could do the same thing with the angle between the negative y-axis and the negative x-axis. That's going to be 5 pi over 4. And similarly, the angle in between the negative y-axis and the positive x-axis is going to be 7 pi over 4. Okay. I only have a few more angles left to fill out. If I took the angle between 0 and pi over 2 and I divided that into 3 equal pieces, each piece would be pi over 6. So I can simply add, I can put a 1 pi over 6 here. Pi over 6 plus pi over 6 is going to be 2 pi over 6, which is pi over 3. And if I added another pi over 6, that would take me here. Adding another pi over 6 takes me here. This would give me 4 pi over 6, but 4 pi over 6 reduces to 2 pi over 3. And then if I added another pi over 6, that'd give me 5 pi over 6. And 6 pi over 6 is what gets me pi. Adding another pi over 6 gives me 7 pi over 6. Adding another gives me 8 pi over 6, which is the same thing as 4 pi over 3. Adding yet another one gives me 9 pi over 6, which is the same thing as 3 over 2 pi. Adding one more gives me 10 pi over 6, or 5 pi over 3. And adding one more pi over 6 gives me 11 pi over 6. All right. So now I have all of my angles labeled. And what I would like to do is I would like to now identify the coordinates of each of these points we have over here. So all those dots is going to have correspond to a point on the unit circle, on this unit circle here, okay? And we want to fill out those points. So before we fill out those points, I want to remind you that we have seen a couple of triangles that we've worked with in the past. So let me reproduce those triangles for you. These are right triangles, okay? So one right triangle we had was, I could write this as like this. So here's one triangle. This one is pi over 6, 90, and pi over 3. And in the past, we may have written this as 1 to 2 to rad 3. However, what I want to do is I want to make sure that this hypotenuse has length 1 because this is the unit circle. So what I'm going to do is I'm going to divide through by 2. So I'm going to have it divide by 2 here, divide by 2 here, and divide by 2 here. And when I do that, you can see that the hypotenuse now becomes 1, which is what I wanted. All right. So I guess the key thing that we want to pay attention to is we want to, when we look at this triangle, we can see that the x value here is going to be 3 pi over 2, and the y value here is going to be 1/2. So I hope you guys could see that when I have this pi over 6 here, that matches this angle right here. So if I wanted to label this point, I could label that point as rad 3 over 2, comma 1/2. Okay. Once I have that point labeled as rad 3 over 2, 1/2, then if I reflect it across the y-axis, this point here will be negative rad 3 over 2, 1/2, right? And if I reflect that point about the x-axis, I'm going to get this point here is going to be rad 3 over 2, but negative 1/2, right? Because this point is just the reflection about the x-axis of this point. So I just negate the y-coordinate, okay? And really, this point and this point here are related, so I could just reflect this point about the y-axis to get this point there, and that's going to give me negative rad 3 over 2, negative 1/2. Okay, so I was able to label 4 of those points there like that. The next triangle that I want to look at is going to be very similar to what we just did there. So the next one looks like this. I'm going to draw a similar looking triangle. We're just going to kind of rotate it. So this time the pi over 6 is actually in the upper corner. This angle here is pi over 3. And then since we just rotated that triangle up above there, then this vertical side is rad 3 over 2, the horizontal side is 1/2, and the hypotenuse is 1. So this time we see that the x value is 1/2 and the y value is rad 3 over 2. And this triangle here corresponds with this, this angle we have here, this pi over 3 angle. All right. So when I go to label these points now, in this case, the x value is 1/2 and the y value is rad 3 over 2. And then just like before, I'm going to now start reflecting this point across the y-axis to get this point. So when I do that, that's going to give me a negative 1/2, comma, rad 3 over 2. I can reflect this point about the x-axis to get me this point. That's going to negate the y-coordinate, so I'm going to get 1/2, comma, negative rad 3 over 2 there. And then I'm going to reflect this point here that I just found about the y-axis to get this point. And that's simply going to negate the x value. So we're going to get negative 1/2, negative rad 3 over 2, like so. Okay. So the last of the special right triangles I want to look at is the isosceles right triangle that looks like 1 to 1 to rad 2. And this corresponds to pi over 4 and pi over 4 like this. Okay. So just like before, I want to make sure that my hypotenuse has length 1. So I'm going to divide each side by rad 2. So when I do that, I get rad 2 over rad 2 is just 1. This is 1 over rad 2. This is 1 over rad 2, like so. And I hope you could see that this angle of pi over 4 is the same thing as this point right here. So I'm just looking at the x value and the y value, and that's going to correspond to the point on the unit circle that I care about. So if I come over here, I'm going to get that this point is 1 over rad 2, comma 1 over rad 2. And now I'm just going to reflect it. So I reflect it about the y-axis. I'm going to get negative 1 over rad 2, comma 1 over rad 2. I reflect that point about the x-axis. I'm going to get negative 1 over rad 2, negative 1 over rad 2. And then if I reflect that point about the y-axis, I'm going to get 1 over rad 2 and negative 1 over rad 2. So for that last point, you could either reflect this point over here or reflect this point over here. Either way, you're going to get the same answer. So the only points I have left to label are the main coordinate axes, this guy, this guy, this guy, and this guy. But these should be easy because they just live on the unit circle. So this point here is 1, 0. This point here is 0, 1. This point here is negative 1, 0. And this point here is 0, negative 1. Okay. So now that I have my unit circle drawn out, I can use this unit circle to identify trig functions. So to do that, I'm going to have sine of theta is just going to be the y value. Cosine of theta is just going to be the x value. And tangent of theta is just going to be sine of theta over cosine of theta, which is equal to y over x. Okay? So if you look beneath each of these trig functions on the bottom row are the reciprocal of the trig function above it. So when I look at the reciprocal, I'm going to have a 1 over y here. I'm going to have a 1 over x here. And I'm going to have an x over y there. And now we can use this to solve some problems. All right, so let's finish off this video by looking at some quick examples. If I wanted cosine of 2 pi over 3, 2 pi over 3 at this angle right here, cosine is going to be the x value, so that's going to give me a negative 1/2. Okay? If I look at sine of negative 5 pi over 6, this one's a little bit different because of the negative angle. I'm going to start over here. I'm going to go negative 5 pi over 6. That takes me here. And sine is the y value. So when I look at the y value of this point right here, that's going to give me a negative 1/2. So I can write it in a negative 1/2 over here like this. Okay. For the this tangent of 17 pi over 4, how am I going to handle that situation? Well, with the 17 pi over 4, that number is bigger than 2 pi. So if you think about it, how many times do we go around the circle? Well, if we started off with 2 pi, but I put the denominator to be 4, that's going to be 8 pi over 4, right? So we have 8 pi over 4 plus 8 pi over 4. That's going to give me a total of 16 pi over 4 plus 1 additional pi over 4. So when I look at this guy, what's happening here? What's happening here is for this first part, I'm going around the circle once and I end up back where I started. For the second part, I'm going to go around the circle again and I end up back where I started. For this last part, I have to go another pi over 4. So the point that I'm really working with is right over here. Okay, so in case it's not clear, this whole thing was equal to 17 pi over 4. So I'm just trying to break down, how many times we go around the circle, which is two full times around the circle, plus an additional pi over 4. So if I want to look at tangent, I need to calculate the y value divided by the x value. So when I look at this, the y value and the x value are the same. So this is basically going to become 1 over rad 2 divided by 1 over rad 2, which is equal to 1. So the tangent of 17 pi over 4 is equal to 1. All right, everybody. This video was longer than the usual 10 minutes, but took a while to explain all of this, all right? Take care.